Welcome to the deep dive. We're seeing some pretty serious issues globally, aren't we? More urban flooding, water pollution getting worse, and, well, our ecosystems are really taking a hit.
They really are. And today we're going to tackle this by looking at something quite specific, but really impactful. The Rainwater Management Credit. It's part of the latest LED standard, LEED+C version 5. That specific credit is SSc3.
Right, SSc3. So think of this as, your guide to how new buildings can actually handle rainwater in a smarter way, almost like mimicking how nature does it right on their own patch of land.
Exactly.
Our mission really is to unpack how projects can do this well, manage that water effectively, and, pick up some valuable LE points along the way.
And it's not insignificant, up to 3 points potentially. This credit is a big chance to cut down on stormwater runoff from a site and, crucially, improve water quality too.
Okay, hold that thought. If you're finding this exploration of our world fascinating and want to delve deeper into future topics, make sure to subscribe so you don't miss out. All right, so let's dive in. What's the actual intent behind this rainwater management credit? What's it trying to achieve?
Well, it's really got several core aims. First, it's about minimizing the sheer volume of stormwater that runs off a developed site.
Okay.
That directly helps protect communities downstream from, well, flooding. Just as critical is improving water quality right at the source.
So stopping pollutants before they even get washed away?
Precisely. Stop them getting into our rivers, our lakes. And there's another layer, too. It encourages restoring a site's natural water balance, looking back at what the site was like before development and trying to get back to that kind of natural hydrology.
That feels like a pretty big shift, doesn't it? It's not just, okay, drain the water away. It's more like, let's manage this resourcefully and maybe even heal the land a bit.
That's a great way to put it. It moves beyond just compliance towards actually tackling these big environmental challenges head on.
So how does a project actually do this? What are the pathways to earning this credit?
There are basically two main options. Option one is based on the percentile of rainfall events.
Percentile of rainfall. Okay, what does that mean in practice?
It means the project has to capture and retain a certain percentage of the rain that falls on the site over a year, specifically based on typical storm events. So you design systems to handle, say, most of the common rain showers.
And how do they hold on to that water? What kind of systems are we talking about? Green roofs and things?
Exactly. This is where you see a lot of low-impact development LID and green infrastructure GI techniques. It's about working with nature. So yes, green roofs absolutely play a part, absorbing rainfall up top,
Right.
but also things like bioswales, which are like vegetated channels that slow water down, filter it, let it soak in. Ring gardens, too, often smaller, prettier versions integrated into landscaping.
Okay.
And permeable paving surfaces that let water just seep right through instead of running off. Plus, you've got rainwater harvesting systems actively collecting water for later use.
Gotcha. So using a mix of these, you aim for a certain percentage of rainfall managed on site, and that gets you points.
That's it. For most projects, manage 80% of the typical rainfall events, that's 1 point. Get it to 85%, it's 2 points. And if you can manage 90% on site, that's the full 3 points for this option.
Makes sense. Now, I saw a note about zero lot line projects having different targets. What are those exactly?
Yeah, good catch. A zero lot line project is basically a building that goes right up to the property boundary. Think dense urban areas, townhouses maybe. There's very little or sometimes no open ground space around them.
So less room for those rain gardens and swales on the ground.
Exactly. So LED gives them slightly adjusted targets for this percentile option. It's 70% retention for 1 point and 75% for 2 points. They can't actually get the third point under this specific option because of those space constraints.
Okay, that seems fair. You also mentioned a bonus point for water reuse.
Yes, this is a really smart addition. If a project doesn't just capture the rainwater, but actively collects and reuses it
For things like,
for non-potable uses. So irrigation is a big one, flushing toilets, providing makeup water for cooling towers or boilers, maybe even certain industrial processes depending on the building type. If they do that with the captured water, they can earn an extra point.
and that's great because it reduces demand on the city's drinking water supply too, right?
Absolutely. It creates a nice circular approach using water efficiently. And like you hinted at earlier, it often helps with credits in the water efficiency category too. Multiple benefits.
It really shows how these sustainability strategies can link up. Okay, so that's option one, the percentile approach. What's the second main option?
The second route is option two, natural land cover conditions. This one takes a slightly different angle.
How so? Natural land cover sounds like it's about the past.
In a way, yes. It's about looking back at what the site was like before any development. The project team has to figure out how much stormwater would have naturally run off the site when it was, say, a forest or a meadow.
Okay, calculate the before picture.
Right. Then they calculate the runoff expected from their new development, the after picture. The goal then becomes capturing and retaining the difference between those two amounts on site.
Ah, so you're trying to make the developed site behave, hydrologically speaking, more like the original natural site did.
Exactly. You're aiming to restore that natural hydrological function as much as possible. Again, using those LID and GI tools, bioswales, permeable paving, etc.
That sounds really focused on ecological restoration, probably good for sensitive sites.
Very much so. It's particularly valuable where minimizing impact on the local watershed is critical, or where you really want to push towards effectively a zero impact outcome on the site's water cycle.
But I imagine you'd need pretty good data on what the site used to be like.
You do. That's the challenge sometimes. You need reliable historical data or good ways to model those pre-development conditions. So it's not always feasible, but where it is, it's a powerful approach.
We talked about zero lot line projects having different targets for option one. Do they get any other considerations or flexibility for this credit overall, given their space issues?
Yes, LED does acknowledge those challenges. For ZLUT projects, there's flexibility to combine what they can do on-site with off-site strategies.
Off-site, like what?
It could mean contributing financially to a larger, maybe municipal or regional stormwater management project nearby, or participating in a shared district-scale green infrastructure system if one exists. It involves coordinating with local authorities, really looking for ways to mitigate their impact beyond their own property lines.
That's practical. It recognizes you can't always fit everything onto a tiny urban plot.
Okay, so if a team is going for this credit, any option really, what are the key implementation tips? What should they focus on?
Good question. First off, really understanding the local climate is key. Detailed rainfall analysis, knowing the site's specific soils and slopes, that foundational work is crucial.
Right, can't design if you don't know what you're designing for. Exactly. And using hydrologic modeling software is, well, pretty much essential these days. It lets you test different designs, see how effective that bioswale or green roof will actually be at retaining the required amount of water.
So it's proper engineering, not just putting in a few plants.
Absolutely. Then actually integrating these LID solutions needs to happen early in the design process, not just tacked on later. Like we said, maybe a green roof makes sense for that dense site. If you're doing rainwater harvesting, you need clear signs, people know what it is, and crucially, a solid maintenance plan so the system keeps working properly long term.
Maintenance is key, for sure.
Yeah.
Anything else?
Collaboration. This really needs the civil engineers, the landscape architects, maybe even the building architects and local planners, all talking to each other from the start. It cuts across disciplines.
Makes total sense. Team effort. So we've dug into the how. Let's step back again to the why. Beyond getting LED points, why is this whole approach smarter stormwater management so fundamentally important?
This is where it really connects to the bigger picture. It's fundamental to building climate resilience. When we manage rainwater better on-site, mimicking nature,
We reduce flooding risk downstream.
we reduce flooding, yes. We also protect our ecosystems. Less polluted runoff means healthier rivers, healthier lakes, healthier coastal waters. It takes a massive load off our existing storm drains and pipes, which in many cities are old and overloaded.
Preventing costly infrastructure failures and, well, basement backups.
Exactly. And ultimately, it strengthens our communities, makes them safer, healthier places to live, especially protecting those who might be more vulnerable to flooding or the impacts of pollution. It comes down to this. Rain starts with a drop. Resilience starts with design. Let's make every project count.
That's powerful. Okay, so to wrap up our deep dive today, LEED V5's Rainwater Management credit gives project teams clear pathways using low-impact development and green infrastructure to seriously cut down stormwater runoff and boost water quality.
Yeah, we looked at those two main routes. Option 1, hitting a specific percentile of rainfall events managed on-site.
Right, the 80, 85, or 90% targets.
And option 2, aiming to match the site's natural pre-development water handling capacity. Plus that bonus point for smartly reusing the captured water.
It's all about mimicking nature to build better, more resilient places. Which leaves me with a final thought for you, our listener. Considering these increasing pressures of urbanization and climate change, how might these principles mimicking natural water cycles be applied even more broadly? Beyond just single buildings, maybe thinking at the scale of whole neighborhoods or even entire cities.
That's a big question to ponder.
Definitely something to think about. If you found this deep dive into smarter stormwater management insightful and want to explore other critical aspects of our world, subscribe now to hear more.